No, I just don't know what that is. And I'm not saying that's a bad thing. I'm saying I don't know what that is. Oh, you think like using the adding angles formula for sine? Possibly. I think it would be fun to try to like, I mean, you can visualize these things, right? If you look at, I guess you could look at u this way, right? And you could look at x this way. And so like for the standard, when I started with, it looks, to start with, it looks like this, right? And then if you let time progress, that becomes this, and then it 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 becomes this, and then right? I mean, it goes wiggle. It pulses back and forth between those two. That mode. So in principle, we could try animating it. We could plot that as a function. We could plot the graph x and let t vary to animate to see what it looks like. Might give us some insight as to what on earth this thing is. Want to try? You can try. I'm kind of interested. Are you interested? I'm interested. Are you interested? The thing is, guys, I just randomly picked the z-squared function. You understand, we could put e to the z there. We could put sine z. We could put cosine z. Those will all generate solutions to the wave equation, which are somehow distant cousins to this fundamental standing wave solution in the W plane. Yep. In my opinion, for like an honors thesis, yes. The very, very hypothetical question for you, yes. Yes, I think so. Well, that was the project. I mean, if something, if something appears and we have to find an interpretation, then fantastic. I haven't found my my muse yet, so to speak. I mean, I do think there's probably an interpretation. Not sure what it is just yet. I mean, this Mater and Rosa paper is very intriguing because, I mean, basically that paper says, think of hyperbolic numbers as two-dimensional space-time. And if you look at a Lorentz transformation in two-dimensional space-time, what's the Lorentz transformation look like? You got time, you got space, right? Well, the new coordinates, x prime and t prime and x prime, new coordinates. Give me a second here. I gotta chase down my sine ambiguity demons. Where'd you go, you punk? Not you guys, me. Come on. Sadness. Oh no. Oh no. Oh no. I decided I'm not buying a new battery because I feel like, the charging plug is like messed up. Every once in a while it says hardware failure, and I think that's like a solid state drive issue. I feel like, it was a nice computer, but its time is done. There's no point in buying a new battery for it. I should just get a new computer, go Linux. So that's what I should do. Oops, don't look at that. Don't look at that either. Oh no. Oh man, I'm gonna have to edit this. Not really, there's nothing to look at. But anyway, where was I? Oh yes, Desmos, thank you. Well, I was trying to find the, so anyway, guys, it's something like this: gamma, gamma beta, gamma beta, gamma. I think there's minuses on these guys. it looks something like this. This is the standard Lorentz transformation. So I'm still in the process of like formulating the ideas for myself. I haven't quite got the words yet, but so that pattern is the Lorentz transformation pattern, right? Matching, off diagonal, matching. I mean, it's the regular representation of a hyperbolic number. So I think it might be fair to say that if a function on the if a function is hyperbolic differentiable, in some sense it means it's like locally Lorentzian or something, because its Jacobian matrix has to look like this. But I'm not, there's issues of like normalization and interpretation. I'm not quite there yet. Preliminary idea, there is more in this modern Rosa paper. He actually they make a specific claim to say that this particular problem is the mathematics of a uniformly accelerated rigid rod, and this is a solution to the wave equation. But the details are missing. The details in that paper, in some sense, are all reliant on this preprint, which I haven't had a chance to figure out if it exists anywhere. So, like, the man behind the curtain is very much hidden in that paper. It's just kind of a list of claims in some sense with a lot of words, but that's not fair. There's lots of details in the paper, but the details we're most interested in are not there, I'm trying to say. All right. So, like, here is a thing I've got sitting in my list of saved examples. This is actually an animation of a solution that they found in 334 at some point. This is a problem I've assigned. And here's a picture of the solution. All right. Yes. Yeah, but I don't want to. I'm going to edit this anyway, you know. I don't want to.
I don't know. This would be good motivation. If they're in 334 and they're watching us, I think they deserve to get that problem.
Yeah, fair enough. All right, so whoa, that's quite a thing, huh? I want sine of x squared plus t squared cosine 2xt. Huh. Well, let's see here. I mean, of course, it's not really like it's bouncing back. It's just that time loops back, you know. Let's make sure our time goes forward all the time. I don't want to trick ourselves into seeing something that's not really there. Can I try to remember? That's an interesting wave, is it not?
It almost looks like it's like turning over the x-axis. Look at it. It's like,
Reciprocal. 1 over z, right? That's, what is that? That's, x minus jt over x squared minus t squared, right? So that would kind of put me to sine of, that would make my u would be x squared x squared over x squared minus t squared squared. That's my u squared, and then plus t squared of the same thing, essentially, right? That's my x. That's my. Oh wait a minute. There's no x. I'm sorry. You're right. It's not as I say. So it's just supposed to be x. Yeah. All right. No square, right? So that's my sine of u. Cosine of what? Cosine of t or minus t. Pick your poison. X squared minus t squared, I guess, right? Is that right? I think that would be the. X divided by x squared minus t squared t divided by x squared minus t squared. How can I tinker with this? There we go. What is that? Ooh. What is that? What if we start with like 1 and go to 2 instead? That's where x equals to t, right? Time, check it out. You can see what's going on, right? Watch what happens as it gets to time 2. Time 1.4, 1.5, time 2. Think about these formulas, right? As the denominator approaches 0, you get infinite oscillations, right? What's that mean? Oh, of course, this is, I mean, look, we've exceeded our, I think we have violated the terms and conditions in some regard, right? 1 over z. But can you reach 0, 0 with 1 over z? Is 0 a value of 1 over z? No. So I'm not sure what exactly that means, but we're seeing that it leads to weirdness. Anyway, I hope I've shown you enough that you understand this wild new way of thinking about finding exotic solutions to the wave equation. Now, if we can find a physical interpretation of these, then we have a paper. Anyway, guys, I'll stop for today. Unless you guys have a question about something. I do need, at some point, to invent for you guys some homework, but I haven't gotten there yet. I'll make it all due the last week. That's right. It's good, right? You can copy Cooper's paper.